everybody. Today we're going to study trig functions again, and we're going to be looking at their inverses. So the first thing that I want you to do is I want you to graph sine, cosine, and tangent. We're going to use this scale. So this will be pi over 2, this will be pi, and 3 pi over 2. Then of course the reverse over here. Okay, and I want you to use that scale for all three of these graphs. Go ahead and do them. You should have no problem doing them. And then turn your computer back, or turn this video back on, and we'll pick it up from there. Okay, so hopefully your graphs look like mine. We've got sine, cosine, and tangent, nothing new there. What we're going to talk about now is what the inverses of these functions would look like. Now we have a couple ways that we can do this. The first way we learned last year is that we can interchange the x and y of our given function and then solve for y. So in order to solve for y here, we know we would have to take inverse sine of each side. That would give us inverse sine of x equals y. And to indicate that it's an inverse, we write it like this. I'm gonna switch these sides around too. Okay, so that's the inverse of sine. So basically y equals the inverse sine of x. If we did the same thing for cosine, it would come out very similar. So we would get, whoops, put that -1 there, inverse cosine of x. And for tangent, same thing. The inverse of tangent is equal to the inverse tan of x. So the question is, what do these graphs look like? Scoot back up to sine here. So one of the ways that we can graph an inverse is to take some points from our given graph and reverse the x and the y. Okay, so if we have this is the point negative pi 0. So I'm going to graph the point 0, negative pi. Over here we have the point negative pi over 2, -1. So the inverse of that is -1, negative pi over 2, and so on. So what we're going to do right now is we're going to label our axes. So now 1, 2, 3, -1, -2, -3 along our x-axis. And our y-axis will now be in terms of pi. So pi over 2, pi, 3 pi over 2, and so on. So the x and y axes have changed, haven't they? -3 pi over 2. And now let's go ahead and graph these points. So 0, negative pi, -1, negative pi over 2. This is the point 0, 0, so that's just going to stay. This is the point pi over 2, 1, which will be graphed at 1 pi over 2. So here's 1 pi over 2. And this is the point pi 0, which will be graphed at 0 pi. So here's 0 pi. And if we look at this, isn't it really just a sidewards sine curve? That is what your inverse would look like. Okay, and it would continue just like any other. It would just keep going and going and going. So I want you to do the same thing now for cosine and tangent. Stop the video, go ahead and do it, and then come back and see if you got it right. Okay, how do your graphs look? Hopefully they look like mine. Here's our cosine, okay? And then this is the inverse of cosine, and again, it would continue. Here's tangent, and then here's the inverse of tangent, right? And they're kind of flipped sideways, rotated 90 degrees. But the problem here is that we are calling these trig functions. inverse functions, but none of them would pass the vertical line test, right? If we put a vertical line here, we would have many times where we would hit these graphs. So what we're going to talk about right now is principal values. This is at the bottom of your page. And the principal values are a part of the domain that makes the inverse a function and not just a relation. Because right now they're just relations. They're sets of points, but they don't pass the vertical line test. So if we look at restricting the domain of each of these functions, the original functions, the inverses will be functions. So the principal values for a sine function go from pi over 2, negative pi over 2 to pi over 2. If we restrict the function to that domain, and then we look at the inverse function, we would only be looking at this part of the graph between these green lines. And if you look at that, that would definitely pass the vertical line test. If we went beyond that, for example, if we went up to here, we would not be passing the vertical line test because we would be intersecting our graph in more than one place. So the principal values go from negative pi over 2 to pi over 2 for a sine function. For cosine, if we restrict it from 0 to pi on our initial function, on our cosine function, when we look at the inverse, this would turn sideways and it would go from 0 to pi. And again, in between 0 and pi, we have a function. So these are the principal values for cosine. It goes from 0 to pi. For tangent, very similar. We're going to restrict this to just basically one of these curves. And we're going to restrict it from negative pi over 2 to pi over 2. Now, the only thing about this is that negative pi over 2 and pi over 2 are not actually defined here. They're undefined. So when we get to the next page, we're going to talk about the notation because these are not actually defined at negative pi over 2 and pi over 2. But if you can see our inverse function, if we restrict the given domain for tangent to negative pi over 2 to pi over 2, when we turn it on its side, this is now a function. Okay, and we like to study functions in this class. So, what does all of that mean? What that means is we're going to have to identify our domain and range. So, first of all, do you notice that we have capital letters here all the way down the line? Those capital letters indicate that we are only focused on the principal values. In other words, the values that will make our given function and its inverse also a function. So the domain that we just talked about for sine went from negative pi over 2 to pi over 2, and it included negative pi over 2 and pi over 2. Looking at our unit circle, remember that? It would look like this. We're only going for that half of the circle. The range, the lowest point of our sine curve is -1. The maximum is 1. Well, this just gets reversed for our inverse or arcsine or inverse sine. The domain is now, oops, I don't know why that happened. The domain is -1 to 1. And the range is negative pi over 2 to pi over 2. They just get reversed. For cosine, remember we restricted our domain to go from 0 to pi, including 0 and pi. And on our unit circle, we would be focused on the top half of the unit circle. And again, our range goes from -1 to 1. Just reverse those for our cosine, and our domain goes from -1 to 1. Our range goes from 0 to pi. And for tangent, remember it was undefined at -pi/2, so we have a parenthesis here to indicate that -pi/2 and pi/2 are not actually part of this. It's everything up to that, but not including it. And if we look at our unit circle, we would have an open circle here, this half of the circle, and then open circle here. The range went from -pi to pi, so all real numbers. And again, this just gets reversed for arctan. So -pi to pi. And the range goes from -pi/2 to pi/2. Okay, so very important that you notice that these have parentheses because the endpoints are not included. And these cosine and sine and their inverses include the ends of the domain. Okay, how are we going to use this? Well, we're going to use this similarly to a few sections ago when we were talking about arc cosine, arctan, when we're trying to solve for angle measures. The only thing with this is we will be focused on only one answer. Okay, so let's take a look. When we look at arc cosine of √3/2, what we're really looking for is the angle that would give us a cosine that equals √3/2. So what we can do is we can take the cosine of each side, because remember, cosine and arc cosine, they cancel each other out. And that leaves us with this equation, the cosine of theta equals √3/2. Now, I've been telling you for a long time, you better memorize that unit circle, because right now, you would be able to just think about, okay, this has a capital C, so I'm only focused on the top half of my unit circle. And where is the cosine √3/2? Well, I know the cosine to be √3/2 when theta is pi/6. Remember, pi/6 is 30 degrees. Why isn't 5 pi/6 included? Well, 5 pi/6 would be over here, and that cosine would be negative, right? So that would be negative √3/2. Okay, let's look at a second one. So the second one, now we've got all this in here. So inverse cosine of 1 plus tangent, inverse tangent of 1. So we kind of separate this into individual little problems. It's the process we just did in example 1, but we do it twice here. So where is the inverse cosine? What angle gives us an inverse cosine of 1? A 0 degree angle. And where is the inverse tan of 1? What angle gives us the inverse tan of 1? And again, remember, for tangent, we're focused on it being negative. I think these were supposed to be capital letters. Yeah, this should be a capital T and this should be a capital C, because we're only focused on the principal values. So we're really just looking here for tangent. And we know all students take calculus. So we're looking down here. So, oops, sorry, it's positive. Second mistake. So we're looking at a 45-degree angle. So now we just substitute those values back in here and here. We get, what's the sine of a 45-degree angle? It's √2/2. And therefore, this whole problem simplifies to be √2/2. Okay? So I want you to look at those. I want you to think about them. And I'm going to post another video that shows the next worksheet. So I don't have it here. that shows the next worksheet with some problems worked out.